This is lesson 4-5, isosceles and equilateral triangles. Now we've already defined these before, so we're just going to talk about their properties so we can do problems regarding the two triangles. So an isosceles triangle is a triangle with at least two sides are congruent. So we have a picture right here of an isosceles triangle because you can see that AB is congruent to BC. Now those two sides that are congruent are called the legs. So the legs are the congruent sides of the triangle. Okay, the legs are the congruent sides of the triangle, and it'll be given to you, or it'll be in a picture and it'll be marked the two sides that are congruent. The triangle can also be turned around, so you can turn your paper so that the two sides congruent, the two legs are on the left and the right if that makes it easier for you. So the legs are the congruent sides of the triangle. The base is the third non-congruent side. So let's label our picture. We have the base, that's the third side that's not congruent. And then we have the legs, those are the congruent sides. So we got two legs and a base. Then we talk about the different angles. The vertex angle is the angle between the two legs. And the vertex angle is the angle between the two legs. So we'll label our picture. Angle B up here is the vertex angle. Okay, the vertex angle is between the two legs. And the base angles are the other two angles. So the base angles are down here, and those angles are actually going to be congruent to each other. We're going to see with the isosceles triangle theorem. So an isosceles triangle is a triangle with at least two sides congruent. We have two legs. Those are the congruent sides of the triangle. The base is the third side that's not congruent. The base angles are down here, angle A and angle C. Those are going to be congruent. The vertex angle is the angle up here between the two congruent legs. So here's our isosceles triangle theorem. It says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So the isosceles triangle theorem, if two sides of a triangle are congruent, so here we have a picture of a triangle and the two sides are congruent, then the angles opposite those sides are going to be congruent. So my two sides are congruent, the angles opposite them, those base angles will be congruent. So if I have AC congruent to BC, okay, those two sides are congruent, then I know that angle A is congruent to angle B. So if two sides of a triangle are congruent, then the angles opposite those sides are congruent. That's the isosceles triangle theorem. We're going to use it in proofs, but we're also going to use it to solve algebraic problems as well. If you need to pause the video to continue copying, then please do so. Now this proof of the isosceles triangle theorem you don't have in your notes, but I just wanted you to see it. So if I have an isosceles triangle, XYZ, and XY is congruent to XZ, I drew this line right here, okay, this dotted line down there, that's added, that's an auxiliary line. So we draw XB, the bisector of the vertex angle. Remember the vertex angle is up here. So if I draw this angle bisector, I now know that angle 1 is congruent to angle 2. And I can prove the two triangles are congruent, and once the two triangles are congruent, then angle Y and angle Z will be congruent by CPCTC. So this is what the proof would look like. Again, you don't have it, I'm just showing it to you. So if you know XY is congruent to XZ is given, and then by definition of the angle bisector, because I drew this angle bisector, angle 1 is congruent to angle 2. By the reflexive property, XB is congruent to XB, so that's another side. Then I can say by side angle side, okay, that triangle XYB is congruent to triangle XZB, so the two triangles are congruent, and then angle Y is congruent to angle Z, since corresponding parts of congruent triangles are congruent. So that would be a proof of the isosceles triangle theorem, and now we're just going to go ahead and we're going to use it whenever we want instead of having to prove it. Now the converse of the isosceles triangle theorem is the opposite. The isosceles triangle theorem said if two sides are congruent, then the angles are congruent. This is the opposite. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. So if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So in the if, the given is going to be the two angles. So if angle A is congruent to angle B, so I know the two angles are congruent, that's the given, then the two sides opposite them will be congruent. AC is congruent to BC. That's the converse of the isosceles triangle theorem. We just sort of switch the if and the then. And we'll do more with converse at the end of the year. Okay, again, if you need to continue copying, that's fine. This theorem is already written for you, and it says if a line bisects the vertex angle of an isosceles triangle, so I have an isosceles triangle, and this line CD is, it bisects that vertex angle. If that's true, then the line will also be the perpendicular bisector. Okay, because remember we showed by reflexive property I could prove the two triangles are congruent. If the two triangles are congruent, then these segments AD and BD will be congruent by CPCTC. And this angle ADC and angle BDC will be congruent by CPCTC, and they'll have to be right angles. So that line will have to be a perpendicular bisector. Okay, and then just a quick thing on equilateral triangles. An equilateral triangle is a triangle with all sides congruent. Okay, you see the word equal in there. So it's a triangle with all sides congruent. And we just have two corollaries. Okay, and those are theorems that can be proved using other theorems. And the first one says, if a triangle is equilateral, then the triangle is equiangular. So equilateral means the three sides are congruent. Then the triangle is equiangular will mean that the three angles are congruent. So if we have our three sides congruent, so if xy is congruent to yz is congruent to zx, then those three angles will be congruent. Angle x will be congruent to angle y, will be congruent to angle z. So that's my corollary that says if a triangle is equilateral, then the triangle is equiangular. Now the converse, if I switch that around, if I switch this if and then, that's also true. If the triangle is equiangular, then the triangle is equilateral. Okay, and think about what angle x, angle y, and angle z will be equal to. We talked about that earlier in the year. And that's it for today.